Hello, geometry students. Mr. Zacek back, and better than ever. I'm recording this for the third time because somehow I recorded the last one and like 5 minutes in it dropped the audio. So I've already got the writing stuff done on here. So I'm going to kind of talk you through what we're doing. Proving a parallelogram, and this is Unit 6, Lesson 2B. So in the last lesson, we talked about properties of parallelograms, and now we can kind of flip those around and use them as a way to prove that this is in fact a parallelogram. So I've listed 5, and then we've got a special case. So number 1, both pairs of opposite sides parallel. Number 2, both pairs of opposite sides congruent. Number 3, both pairs of opposite angles congruent. And number 4, the diagonals bisect each other. Number 5, consecutive angles are supplementary. So if we can prove any one of those things, then that is our reason. So if we want to think about this from a reason standpoint, it's kind of like if any one of these, then we can make a conclusion that it's a parallelogram. All right, there is one special case, and that special case is one pair of opposite sides parallel and congruent. The key is it has to be the same pair that is parallel and congruent. All right, so we're going to work through now this first question. For what value of x and y must PQRS be a parallelogram? Well, in order for that to be a parallelogram, opposite sides must be congruent. So that would look like PQ would equal SR and PS would equal QR. So if we take PQ, which is 3x minus 5, and we set it equal to 2x plus 1, we add 5 to both sides, we subtract 2x, we find that x equals 6. Okay, then PS and QR, PS is x plus 2, QR is y, so we do 6 plus 2 equals y, and we get 8 equals y. So again, the 6 came from what we had already solved for the x. All right, so the next one here is, for what values must this thing be a parallelogram? Well, when you're looking at angles, you got two options. Opposite angles are congruent, consecutive angles are supplementary. The issue in this one is if you go ahead and look at opposite angles and set them equal to each other, they both have x and y. So instead of doing opposite angles equal, I'm going to go with consecutive angles are supplementary. That looks like h plus e adding to equal 180. So we plug those in, y plus 10 plus 3y minus 2 equals 180. Combine like terms, 4y plus 8 equals 180. Subtract 8, divide by 4, y is 43. Okay. When we come over to the other side, we've got angle F and angle G. Okay, the measures of angle F plus the measure of angle G is 180. So 4x plus 13 plus 12x plus 7 equals 180. Combine like terms, 16x plus 20 equals 180. Subtract 20, divide by 16, and we get x equals 10. Okay, next one. For what values of x, I'm going to pause here while that bell rings for a sec. Okay. For what values of x and y must ABCD be a parallelogram if AC is 16, AE equals y, BE equals those? Okay, so the property here is the diagonals must bisect each other. And you can see the tick marks that I put here. That means AE must be congruent to EC, and DE must be congruent to EB. So if we start with the ones here, the x ones DE equals BE, 2x minus 10 equals x plus 5. So you subtract x and you add 10, you get x equals 15. Now, in this other one, it's important to identify that AC is the entire length of this. So when you get AC equals 16, That's the full length. So that equals 2 times AE. So 2 times AE equals AC. So if we substitute in AE is Y, AC is 16, we solve and get Y equals 8. All right, so the last one is if AE is equal to CE and DB equals 2DE, can you prove that this is a parallelogram? So I just marked that on here, AE and CE, those are both 14, and then if DE is X and DB, that's the whole segment, is 2X, that means BE also has to be X. And so therefore, that's a parallelogram because the diagonals bisect each other. Okay, and so if the diagonals both bisect each other, then the figure is a parallelogram. All right, I recognize that I'm going a little quickly here with this, so feel free if you have to pause the video as you're writing things down, go ahead and do that. All right, so let's go ahead and look at the next one. I'll put the screen up to try and help our focus now. All right, so we're given these things, and the question is it a parallelogram? Now, I don't want to right off assume that X is 131, even though I've got it drawn on here. Okay, this is the conclusion that I came to from the work that we did. See, what I know is that all of the angles and the inside of a quadrilateral have to add up to 360. So the measure of angle X plus 49 plus 49 plus 131 equals 360. That's going to be the measure of angle X plus 229 equals 360. So the measure of angle X equals 131. Okay, so therefore it's a parallelogram because both pairs of opposite angles are congruent, so, or equal. If both pairs of opposite angles are equal, that's a parallelogram. Okay, now can we prove that this quadrilateral is a parallelogram? And in this one, the first one, there's not enough because it is not the same pair of opposite sides that are parallel and congruent. Okay, so if we think about our reasons, both pairs of opposite sides are parallel, both pairs of opposite sides are congruent. We don't have that one pair of opposite sides parallel and congruent, and in this case we don't have that. Okay, so that's kind of the trick one wants to pull us in. Okay, I'm going to do a proof here. So in this case we've got our givens. I kind of tried to fit it in the space here, so I just sort of made my statement and reason up here for number one, what we're given. Number two, I said is ln is congruent to ln. We know that by the reflexive property. So at this point, we've got triangle LAN congruent to triangle NDL because angle side angle is congruent to angle side angle. Well, what does that allow us to do? Well, what that allows us to do is it allows us to say that AL and ND are congruent to each other. DN, okay? And it also allows us to say that AN and LD are congruent to each other. So, because corresponding parts of congruent triangles are congruent. So therefore, LAND is a parallelogram. Why? Because if both pairs of opposite sides are congruent, then it is a parallelogram. Okay, now some of you look at this and you're probably thinking, well, couldn't we have said that the opposite sides were parallel because alternate interior angles are congruent? And you would be exactly right. That's a perfectly acceptable method of doing that problem. Okay, I just chose to do it this way. Okay, now this one here is a truck, sits on a platform on a vehicle lift. Two moving arms raise the platform until a mechanic can fit underneath. Why will the truck always remain parallel to the ground as it is lifted? Well, if you look at this figure, what you notice is both pairs of opposite sides are equal. And so since both pairs of opposite sides are equal, the lift will always be a parallelogram and therefore parallel. That's one of the properties, right? Opposite sides of a parallelogram are parallel. So then the next part, what is the maximum height that the vehicle lift can elevate the truck? Explain. Well, it's going to be 6 feet when QP is perpendicular to PS. So once it's perpendicular, that's the highest it could be, is when it forms that rectangle, and we've got that figure there. Okay, so the thing you want to study really from this lesson is these kind of 6 reasons. Just bring you back to the beginning. Those are going to be very key for you. It's one of those things that would be worth making a little note card or to look over, so you've got those reasons familiar in your own mind and in your thinking. Okay, good chatting with you. Good luck on the assignments. Let's ask and keep on asking questions. I'll see you soon.